Okay, this next part is called the central limit theorem, and there aren't any questions per se on this, but we have to just explain what's happening. So the mean and standard deviation will vary for different samples. Okay, we've talked about that before, and as the sample size increases, the variation should decrease and become closer to the population mean and standard deviation. So we've talked about that before, and so what we're looking at is what happens to sample proportions. Okay, that's the big question. Okay, so the distribution of a statistic for many samples is called the sampling. Okay, so we've got sampling proportions, and then the distribution of the statistic is called the sampling distribution. And as the sample size increases, this is the important thing, as the sample size increases, the distribution becomes more like a normal distribution, okay? So you're going to have some results at each end, but most results for the sampling will be in the middle, okay? That hopefully makes a bit of sense. So what we've got is, as the probability of success is close to 0.5, the sample proportion approximates a normal distribution. So the closer it is to 0.5, the better it is. But also the sampling size also has an effect, and this also affects how close it becomes as well. Okay, so copy that down and come across. And so we end up with this guide. Okay, so obviously we want P to be close to 0.5, but we've got this other thing. If NP and NQ, so they both have to be greater than 5, then we can use this normal distribution for the sample proportions. So we're talking about proportions still, and we're going to apply the normal curve to it in the future questions. Okay, but we've got to do this check first. NP and NQ both have to be bigger than 5. And so once we've got that, then we have the mean and standard deviation. So we had this on our previous videos. The mean is NP, and standard deviation square root of PQ over N. Okay, so copy that. We've had that before. Okay, so copy and come across. Okay, so what we've got is this little bit. So the central limit theorem. So for relatively large sample sizes of the variable x, okay, so the mean, we use this letter mu, okay, and standard deviation we use the letter sigma. And so what we've got is the mean will be equal to mu, and the standard deviation of the variable will end up being this formula here. So it's slightly different, but we're going to use that formula for future questions. Okay, so copy that and come across. That's it. So there aren't any questions to do with this, but we'll be exploring these things in our next videos. Okay, bye.